Today we're going to talk about complex fractions, which are basically fractions within fractions. Now, there's multiple ways that you can approach these problems, but I'm just going to show you one method. If you have another method you prefer to use, that is perfectly fine. The method I'm going to show you, though, involves finding the least common denominator and then multiplying every single term by that LCD to clear the fractions. So let's just start with an example. In this first example, we have denominators of 6, x, 3, and x. My LCD is 6x. That contains the factors 6, x. There's a 3 inside that 6, and then the extra x. So I'm going to take every single term in that complex fraction and multiply it by 6x. If I do this correctly, I should be able to cancel out every single denominator. First term of the numerator, I can cancel out the 6's. Second term of the numerator, the x's. And I'm left with x squared minus 18. In the denominator, 6 divided by 3 is 2, so we're left with the 2x, and then we can cancel out the x's. So the denominator is 2x plus 6. Finally, I would factor to see if there's any common factors. The only thing that can be factored here is the denominator. We can write that as 2x plus 3, but there are no common factors. There's nothing I can cancel out, and so this is my final answer. All right, let's try to repeat that process on a few more problems. So example 2, the only denominators I see are x. That means my LCD is x. So I'm going to take every term in the numerator, multiply it by x, and then every term in the denominator and do the exact same thing. When I distribute, I'm left with x squared minus 2x plus 1 in the numerator. Notice in that last term the x's canceled out, and we were just left with the 1. In the denominator, I have x squared minus 5x plus 4. Again, in that last term, those x's canceled out. Finally, I have to see if I can factor and simplify. So numerator, product of 1, sum of negative 2. That would be x minus 1, x minus 1. In the denominator, we've got product of 4, sum of negative 5, minus 4 and minus 1 work. So it looks like I have a common factor of x minus 1. I cancel that out, and my final answer is x minus 1, x minus 4. Example 3. Now I have denominators of y and x, and so my LCD is xy. So I'm going to multiply every single term by that LCD xy. In the numerator, first term the y's cancel, second term the x's canceled, and we're left with x squared minus y squared. In the denominator, we get y's and then x's canceling, and we're left with x plus y. Finally, I should factor to see if I have any common factors, and I notice that the numerator is a difference of perfect squares. We can factor that numerator as x plus y, x minus y. My common factor is now x plus y, and I'm left with an x minus y. All right, one more example. We're almost done with today's video. We're going to start by finding the LCD. So exact same process. My LCD has to have an x plus 2 and has to have a 2. That's it. That x in the denominator isn't actually a fraction. You can think of it as an x over 1. And so the LCD has to have just the x plus 2 and the 2. So just like before, I'm going to multiply every single term by that LCD. Second term, the 2's cancel, and I'm left with an x plus 2. Notice I kept that x plus 2 in parentheses for now, because I want to remember that the subtraction is actually going to apply to both of those terms. In the denominator, nothing cancels out. I'm just going to rewrite that as 2x, x plus 2. So if I distribute in the numerator, I have a 2 minus x minus 2. I distributed the negative sign. And when I combine like terms, all I'm left with in the numerator is that negative x. And my denominator is still 2x, x plus 2. Finally, I look for common factors, and I see one this time. I actually have a common factor of x. If I cancel that out, I'm just left with a -1 in the numerator and a 2x plus 2 in the denominator. So to summarize, in these problems, we find the LCD, and then we multiply every single term by that LCD. If you find the LCD correctly, you should actually be able to cancel all your denominators out, and you're left with something that is no longer a complex fraction. I hope this makes sense, and of course you can always ask me questions if it doesn't.